So our presentation today is more of a use case of what do we do within market regulation, so specifically financial market regulation, and really how do we make data usable is really what our talk is. I'll touch a little bit on some of the nuts and bolts of like what it is that we do in different solutions, and if I don't get deep enough, we can always talk some more either offline or afterwards as well. So let me just give you a little introduction about myself. I've been at FINRA a little over 13 years now. I'm responsible for our big data analytics, as well as that's in our market regulation area. So we regulate the various different markets. I'm also responsible for our systems that deal with insider trading and fraud detection, as well as some real-time market monitoring systems. So what is FINRA? Most people don't know us. It's an acronym, so it's Financial Industry Regulatory Authority. So what we do, our mission, our goal, our objective is to protect the market. It's to protect investors such as yourselves who are buying and selling stocks, that are buying and selling corporate bonds or buying and options, and to ensure market integrity. So we do this through a variety of ways in terms of where we bring in and accumulate literally billions and billions of market events every day. We currently have, like as this one says, we have a little bit over 2 petabytes online up in the cloud. We actually have more than 6 petabytes of that sitting in offline storage that we have to be able to recall if we need to. But we do a variety of different mechanisms to protect it. And we have sort of our 3Ds is that we deter misconduct, we enforce the rules, we detect and prevent wrongdoing, and we discipline those that actually break the rules in a variety of different ways. So a little bit more on what we do. I mentioned on the prior slide, we bring in roughly over 33 billion events per day, and that varies day to day. You'll have market volatility. Just back in October, we actually had days where we passed over 55 billion events. We bring this in from a variety of exchanges, national exchanges, in the equities, in the options, and the fixed income markets. That's sort of our jurisdiction of what we can provide regulation around. We don't do the futures markets or other derivative types of products, nor do we do like US Treasuries or securities in that realm. But really what we do is that we bring in all of this data from all these proprietary exchanges, have to mesh it all together, and then we run a series of surveillances across this. We try to identify market manipulations, insider trading, as well as other just compliance violations that can be anything from more traffic ticket type violations in terms of data quality, data integrity, timeliness, to these more esoteric manipulations. And then effectively we enforce the rules, and we have a variety of ways that we do that. We can either fine them, we can disbar them, we can basically pull their license and take them out of the industry. In any sort of criminal matters, our purview is really on the broker-dealers, but we are not an arm of the SEC, but we work in conjunction with the SEC, and so we'll refer criminal matters over to the SEC to pursue that they take from that matter. So a little bit more on like what it is that we do. So some of these words you probably have heard. So insider trading, like are people actually buying ahead of the market, right? So they're working on news, they have insider information. Fraud schemes, pump and dumps, boiler rooms. We're trying to look out for you as an investor in terms of, are you paying the right price for your stock when you submit your order? Things like best execution and order protection and front running, where somebody actually jumps ahead of you on an order and then you're playing a disadvantage. You're paying too much for a stock, or you didn't sell it for enough. And then there's other manipulation techniques where they try to influence where the market is headed, and indicative types of things like layering and spoofing, where they try to show where there might be interest in the market, but it's actually not really there. So they're actually trying to defraud the market in that regard. So what we do, some example cases of what we've done in the past. We've had where we've taken various different firms like Karis and Beremus Corp, and these guys have all been fined and disbarred from the industry. We levy fines and we'll do restitution for that. We've levied fines in the ranges from hundreds of thousands to millions of dollars, as well as done restitution back to the investors as a part of our investigation, so that actually money goes back to them where they were actually harmed in that regard. So specifically, what are we doing with big data analytics? And the way I kind of look at this is that really what we try to do is create a dialogue with the data. So the big data and having all these billions of transactions and having several years worth of this data online, has all of its problems and challenges, but at the end of the day, the people that are using this data are lawyers, they're financial analysts, they're regulatory staff. These are not data scientists per se. They're not going to be writing Python, they're not writing SQL, they're not writing R scripts around this. We do have a class of users that do that type of activity, and they do our prototyping as well as interpret the rules. But what we have to do is really kind of make the data easy for them to use. So this goes back to really just user design tenets. And a couple of the ones that we really drive towards are to make it easy, to make it engaging, to make it efficient, and ultimately that makes it effective to get back to the users. And in this area, we have different ways that we can converse with the data. In some cases, we know they're asking questions of the data to really build this story. In some cases, the questions are very, very complicated, and they are very specific types of questions that they will do. And we will specialize and optimize around that facility. To the other end of the spectrum is that they're very open-ended and unpredictable questions. We have a variety of different work groups or domains within the department that specialize in different areas of market manipulation, and the types of questions that they ask of the data is everybody is a little bit different given this circumstances in the case that they're looking at or investigating. And then they're anywhere along that spectrum between specialized and open and unpredicted, where we might do some specific market reconstructions. But one of the things that we do along this way is that we constantly are monitoring and learning from what questions that they're asking of the data. So a big thing is that we constantly log and monitor that, and we create a feedback loop off of that. And once we know enough around that, we can actually take it to the next level, and we actually start to author the story for them, is the way we look at this. In this is that we have the set of questions that we know that they're constantly looking for, so we can actually kick it up a level and actually pre-build that for them, present them the story as we see it from the data. Now they can do the next level, which is moving on and creating the connections and the inferences out of the data that allows them to connect the dots and be able to move that through. And so what I'd like to do is walk you through a few different examples of these types of market reconstructions in the different areas that we walk through. So the first one that we have, a use case, is where we're trying to investigate instances of front running or wash sales. The net of this, to be able to do this, we need to know where your order, where that event appeared in the order lifecycle. An order lifecycle is when I go into E-Trade or Bank of America and I submit my buy or sell order. That gets aggregated. It may get routed and executed in a variety of different ways. My order might be aggregated with your order and it became a block trade. It might get routed to a dark pool. It might be internalized. So there's a whole series of events, a giant network graph effectively of all of these routes and cancels and movements that occur. And the only way to properly investigate these is to know where any particular event, where it came from and where it went to, so you can see the entire picture, and then you string these stories together to be able to answer. And the problem with these is that they're very expensive queries to run. They're long-running recursive types of queries, and we used to, because there was such a volume of data, the constraints that we had is that we would only run them when the users asked for them. And these queries would take minutes, hours, sometimes days, or not even return. We had like some queries that would actually just take down our data appliances. So you couldn't even like ask the question because some of these trees and nodes were so long. And that effectively that you lost interest in it. It was, when you're having a conversation, if every time that you're saying something, like if it was like the old time, satellite television, right? It's like out there and you lose the conversation, you lose your momentum of what it is that you're trying to ask of the data. So it became impossible, and so it was this disjointed asynchronous operation that the users were interacting with the data. So what did we do to solve that problem? My peer actually, Tigran, presented a little bit earlier on reconstructing the stock market overflow, which was much more the nuts and bolts conversation of the solution that we call our fast order lifecycle. The net of this is that we went and we basically pre-computed all of the lifecycle, all of the graph possibilities each and every day. We back processed over 2 years worth of that data, and the net result of it is that we ended up with an HBase cluster where we stored this data that has over 1.3 trillion events inside of it. So at any point in time, you can go and ask the question of where did I come from or where did I go to? To be able to enable this, we spent a lot of time, working really with Cloudera, and with our HBase implementation around how did we actually optimize this. So a big part of it was how did we actually create the database in the first place, and then secondly, how do we get the data out in an efficient manner. And that required a large number of, I'll say, perfections that we ended up doing to this, which is that we didn't do standard puts. We actually generated the H files and did a bulk insert of the H files into these. That we actually removed doing like major compactions in the HBase so that we wouldn't be disrupting it, and that we actually inserted the regions so that we would the H files onto that, and so we salted the keys to be able to make sure that we could predetermine exactly where they would be. So we basically took the HBase sort of the compaction and the redistribution inside of that, took that out of the equation so that we could maintain a fast and orderly operation. On the get side of this is that it effectively became like a three-part get. The way we typically would come into an order lifecycle is I would have some trade or some order that I was interested in that a user would get what we would call like an audit trail, which is basically here's some time sequence of events that I was interested in. From there, I'll go to the order lifecycle to be able to peer into that. So we would take that order lifecycle, we would find basically the primary key or the root parent of that, what tree did it participate in, fetch all the trees, and then the third fetch would actually grab all of the details. But just showing them the details isn't enough, because some of these trees, I've gone from trillions, some of these trees in and of themselves might have millions of events inside of them. So what we ended up doing is to make it even simpler is to summarize the various different information so that they could see all of the firms and all of the event types by firm and where they routed, where it was canceled, so they could, if they wanted to, make a quick determination of that and then drill down into the details around that. The other thing that we really focused on is how do I make this easier to use, because no analyst is working in isolation. So we didn't want to keep multiple copies of this, so we enabled deep linking really, so every URL was unique and they could pull that in, they could put it into their case file, and then I could share that with other people. So anybody who clicked on that link would go right back to that order lifecycle, exactly what the other person saw. And then the third part on the usability aspect was really making it usable for them, really simplifying down the interface and using just good user interface design. We brought in a couple of UI designers around this to really simplify the interface instead of having engineers kind of develop an interface, which ended up looking like, as my one project manager said, it looks like the cockpit of a U-boat, where some of our old applications look like, and to really simplify and streamline that. The net of it is that we allowed the personalization and the customization of the data that was coming back to them to allow them to move and order the columns, allow them to do other operations on this so that it could best fit their particular business class, their domain of what questions that they were trying to answer. They save those preferences, and now every time they go back there, it's the same each and every time. They don't have to reset that. So the net of this is that we literally took, the impact off of this is that effectively we took something that was this long-running asynchronous operation, and now you could actually interactively and pull on various different threads. You could have a dialogue actually with the data and have a conversation with it. It gave them a fast, interactive experience where now I could move and be able to pull around on this data. Part of our job in technology is to solve difficult problems and to make it easy for the user. And so we always want to make sure you're taking the user into account and what is the type of user that's going after that. But effectively it allowed them to construct the story. And I know it was fun for us when we actually demoed like the final product to them. We actually got a standing ovation from about 200 users, which was like, it literally changes their behavior. It changes what they can actually do when you actually make an impact around this. As they were saying, like now they can quickly, this is a quote from our one vice president, her analysts can actually go out there, they can quickly make a determination of a rule violation. This makes our processing and much more effective and efficient as they're doing case investigations within regulation. Now at the other end of the spectrum, we have sort of the open-ended and unpredictable. And the challenges here is that everybody's questions that they ask is unique. Everybody wants a different set of data. They want to see the slice a little bit different. They want to have different data sets inside of it. What we do at FINRA, from these various different exchanges, we have a little over 300 various different unique data sets that we bring in from the exchanges. Some of them are order information, some of it's trade, some of it's reference data. But they need to be able to correlate all of this various different data. So one of the other items that we dealt with is just sort of capacity constraints. How much data that we could be storing in our data appliances, how much we could have in our various different databases. And it became a shuffling exercise because the users, it's a regulatory agency. And so one of the things that we had to have is full fidelity. We had to have like the full retention of all of the events. We can't summarize trading activity. I can't make a case against an aggregate or against a statistic. I have to make a case against a sequence of events that occurred that showed Joe did X, Y, and Z in this order on these dates, and typically show a pattern and practice of that to be able to actually make a legal case. What that ended up resulting in is drag. So the tools that we had and the databases that we had couldn't serve these queries, so then these became little one-off mini projects where the business users would call up people in technology. They would have to write like a little custom query or custom program, put that together, throw it off to the side. So effectively, technology was in the business process. Like they couldn't do their job without technology, and part of technology's job is to reduce friction. It's to remove that aspect and make it easy for them. And again, the volume of this data, because now we are spanning, again, multiple years worth of the data. So what do we do on this particular side is that really what we said is we did some really basic summarization on the data. Because there were at least a couple of attributes, an issue symbol like Microsoft, Apple, Google, or a firm, Merrill Lynch, Bank of America, there's a handful of attributes of what the users are going to have to be required to ask of the data. Even some of these attributes, some of these data sets that we're dealing with have 120, 200 attributes wide that they are looking at of various different sale condition codes and time in force and order protection codes that they deal with. And so we said, look, we'll summarize this because a lot of the times the users don't even know what it is that they're asking for. So at least give them some basic ideas of, you recognize that you're trying to pull back 1 million records, 10 million records, 100 million records. Are you seriously going to sift through 100 million records, right? Out of the trillions that were out there, depending on what they asked. So we tried to make that easier for them. From there, then what you can do is actually refine that data back out of there and create a small private data mart. So now we've taken it out of this giant data lake, which we primarily used S3 for that, and we're storing the data in organized files. We were doing it within Orc, is how our initial implementation is, and running Hive queries off of that, then throwing it into more of an OLAP type of a database. Right now we're using Redshift for that, and then we stash the data into that. So now I've taken it from trillions, typically down to like millions. Now I can much more interactively work with the data. And then we developed a custom UI around that allowed them to sort on the data, filter it, to pivot it, to be able to summarize on that, take various different actions with the data so that they can move and annotate the data, and then actually start one of the things that, well, we don't have annotation yet. One of the goals is to be able to, one of the features that's on our roadmap is to add in annotation. So now within these different data sets, start annotating the records that are the ones that are relevant for your case so they can show the context, because no independent set of transactions are in and of themselves. You have to show the context of the market of what was going around on this. And so one of the challenges of is the volume, is the velocity of the types of transactions, is that we're dealing at items at the microsecond or even at the nanosecond level. And so dealing with order inside of all this data is extremely difficult because the different exchanges don't necessarily give us the exact same timestamps around this, and we're pulling it in from various sources, and everybody syncs to the clocks, but there's still some drift, and so you have to account for this within the rules of how we display that data back to them. But really the magic that was around this was optimizing the different data structures off of these issue in the firm so that you could still take an operation that used to take days, that was this mini project, and now it's doing it in minutes to create this private data mart. Then from there, now you're working interactively, so every action that you're taking is taking a second or two for it to work, and you can have that conversation again with the data. The other thing again was customizing the displays and really just looking at the usability factors around this. But the impact around this was what, excuse me, what we say is we've lowered the cost of curiosity. It allows the investigators and the analysts to go out there and pull on threads, be able to pursue new avenues of investigation and be able to take around that. It allows them to more intuitively explore the data around this, so you can pull on the threads, and now they actually start asking more what if questions. What if we were, what if this particular transaction, or I see this particular one, before analyzing the data could be too difficult. And the net effect is what I say is that I call it the Ganesh effect. Ganesh is the remover of obstacles, and we took technology out of the way of the business to actually do their job. So the quote that we had from our again from a different senior manager, was that data analysis of this magnitude usually took the technology team. It took them days or weeks to be able to kind of put together these types of data sets. And now this is an operation where they create their data mart in a matter of minutes, and now they can conduct their analysis on that in a matter of seconds. The last area that we really kind of hit on was an area of what we call is our insider trading. So in this area, we've been doing this. So what we do at FINRA is that we have an agreement with all the exchanges for both the equities and for the options. So we are the utility that does insider trading detection for both the U.S. equity and options markets. And this is all U.S. equities and options markets. So we are the go-to folks in that regard for the exchanges. And within this, the insider trading, there's a different mechanism here. So somebody's typically taken a position before a public announcement. So whether it be a merger and acquisition, a new product announcement, a bankruptcy filing, your CEO getting jailed, right? These are all market-moving events that occur. And so if somebody's acting on this, from the realm of insider trading, I don't really care if the stock went up or down or sideways, after the event was announced publicly, but it's all the activity that occurred the day, the time before, the minutes, the seconds, the days, the months, before that activity is what's interesting. And an insider trader rarely works in and of themselves. There's a ring, there's a network here that occurs when you have this. So being able to quickly identify this and then being able to take action upon this, for instance, where we would make a referral back to the SEC to freeze their assets. We don't have that purview ourselves, but we'll give referrals over to the SEC that can take that action. The complexity is that there's a variety of different networks and a number of different structured and unstructured data sources that we have to consume around this. So an analyst before had to bounce around to a lot of different systems. And again, what we have here is just hundreds of billions of transactions a year where we have the beneficial owner information that we can look to try to mine this to actually identify these networks. So what we did here was a slightly different picture. What we did is that we built a profile. We built the story. So we had all these pockets. We had case information. We had prior case information. We had different searches that we could be able to do. We had news events. We had net position information, as well as unusual activity file, which basically is an industry blacklist of known traders and people that have been identified previously. And so what we did is that we aggregated it and consolidated all of this into an easy profile. So every time that they would be investigating a case for this particular instance and the trading activity around that, we would calculate for that. We would they would look at their positions that were taken in that, determine their net, a few different metrics in terms of their profit potential or their loss avoidance in case if you were doing a short selling. It allowed them to quickly see, was this the type of a person? Maybe this particular instance wasn't, is it something that was outlandish or not? But also you could see, okay, I see a guy here that might be repetitively flying sort of below the radar screen. Now he's on my radar screen because I don't have to rely on a search, that making sure that there's a manual process that somebody typed in Scott Donaldson into our enterprise search to see did he have any prior cases. We're doing that for the user and actually providing them a picture right there where they can make a determination. The goal out of this then is that it allows the users to start to take this information and connect the dots between the various different people. And we have other analytic tools that allow them to try to identify that. You're looking for geographies, we look at chronologies, who knew what when, as well as who talked to who, and then you can start to actually piece these things together. And this is really where an investigator steps in and then be able to put these networks together. So, examples like this are the Galleon, the SAC Capital case. There's a variety of different schemes that go on in this area that, you try to piece together the pictures of the puzzle. It may be a maid that was picking up information that some trader was investment banker was leaving on his desk. It may be the case, there was the more recent case last year that the SEC brought, which is where a guy was dropping off notes in Grand Central Station. And literally it was an old, you think of Jean Le Carre, right? He was dropping off an envelope at a seat in Grand Central Station. The guy would pick up the piece of paper, look at it, and he would eat it, right? And so, these are the types of cases that you end up running into, inside of this. And so there's lots of interesting details that come out of these guys and the lifestyles that some of these guys live. So the technologies that we really used in this we were using like Solar. We had our reference data, and this one in case of like Angular, and then a custom development around this. So, those are a couple of examples of what it is that we've done and where we're trying to go within market regulation. The net effect is, again, speed and efficiency. Trying to piece together all this information. You've taken it out of the hands of relying on somebody to do some manual steps and manual procedures. We've automated that for them. Now they don't have to worry about, it is a regulatory agency and there's a set of process and procedures that they need to do to make sure that they're conducting the investigation in the right way. Effectively, we've done a portion of that for them, that they don't have to do that anymore. It allows them to quickly draw these connections between the different stories and easily explore these lines of investigation and pull on new threads. And again, the idea of this is lowering the cost of curiosity, really, really making it easy for them to have that conversation with the data. So with that, where are we going next? There's a couple of different areas. So one, where we're trying to drive at to continue to kind of build out our analytics solution. One is dealing with sort of data blending and the virtualization layer. We have some limitations right now within our reference data, especially when we're doing like long look back periods. Everything that we deal with in market regulation, and this is probably, this is my world in general, everything is a slow changing dimension. Everything changes over time. So, one of the things that we try to take account for is that the transactions that we have, because we are keeping 2, 3, 4 years of this data, is redesigning our schemas and our layouts so that we can change, that the transaction events themselves will change over time, that the reference data tied to that changes over time. Companies get bought and they sold and they merge and they change their ticker symbols. The firms change names. So we need to be able, when I'm like looking for a company that used to be XYZ Corp and now it's AAA Corp, I only know the current symbol, but when I type that in and I'm running that query over a year or a month, I want to pull back all of the results, not just the ticker symbol that we had. So that involves us to be able to actually insert some more smarts into the querying parts of the engine to be able to do that. One of the other steps, again, just driving the layer of efficiency. So once they have this data set back, and now that they start taking some actions and they pivot and they've pivoted and they've summarized it and they've narrowed it down and they've taken these set of actions against the data, what I want to be able to do is actually save that data as a macro, right? So everything that they do is a wash, rinse, repeat. We have analysts that are specialized in wash sales or in a particular domain. It's the same analysis over and over again against a new data set. So it's a different ticker, it's a different company, a different date, a different time slice, but they're doing the same thing over and over again. So let's continue on this ease of use perspective to make it easy for them. We'll continue to kind of build out some more specific market reconstruction tools. So where we see common patterns of behavior in this, unpredictable and open-ended questions, as we monitor and we observe behavior, we can start to take those and push those more into the specialized and optimized area, that we can start to predict what questions that they are doing around that. The other area that we're really looking at is, kind of the evolving SQL on Hadoop and in the big data spaces. There we right now are primarily working with Hive, but we're looking at other tools like Presto, as well as like Impala and some other tools that are out there to see what makes sense for us as this is a fast evolving market space, and we're all about trying to make the queries fast and efficient. We'll trying to architect our solutions that these things become pluggable architectures, pluggable pieces within our application architecture. The next thing then really is just binding these analytics back to the business procedure. It's a company of regulators, it's a process, it's a workflow system. That's where they live and that's where they live at. It's, whether you're processing, insurance claims, but there's a workflow that all of these actions have to go through. We have to manage cases, there's aging metrics. So how can we better tie the analytics back to the specific surveillances and the patterns that the different users are working through? Being able to move that back and actually have tight integration there within these various different data sets that they work with. So with that, I forgot to actually put together a little takeaway slide, but a few different points I wanted to highlight on that are really takeaways that we really try to advocate. One is simple. One, just don't forget the user, right? Make it easier for them. I kind of have what I say is E cubed equals E. It's make it easy, engaging, and efficient. That makes it an effective solution. part of our job in technology is really to take the difficult and make it easy, right? Otherwise, we wouldn't be getting paid for the job really that we're doing. The other item is that in technology, for us to be cost efficient, I'm an internal IT shop, is I need to take technology out of the way, and that means self-service. That means I cannot be writing reports and having a library of like 500 different reports where everybody wants to see it a different way. It's giving those layers of personalization and customization back to the user and let them customize the output and the determination back to them so that they have the power to be able to do that. The users now are much more adept to that. Even though I have like some very old, we have some older lawyers and folks that have been around for a while, but even they get that and they understand and they appreciate when you give them the tools and the capabilities to do that. Now it has to be, the idea is again making it easy and engaging for them so that they don't lose that it makes it in there. And then really the last item, or two other items that we really have learned along the way is it's okay to have multiple copies of the data. You need to have one golden source that you hold that is the truth, but to be able to solve these different problems, to make really big data available and make it easy for them, is don't be afraid of having multiple copies of the data. We have some very specialized solutions like where we're throwing it into a NoSQL database like an HBase. We've looked at like Cassandra, but you're going to end up with some specific point solutions that solve a problem, but you can do it in fast and efficient. There are other ones where you need to have like a copy of the data where we're doing it like over on S3. If you need to have 2 or 3 copies of the data to solve the particular problem, put the right tool onto that. And that was one of our big constraints that we used to have really within our organization is like we only wanted to have 1 copy of the data. And there's a reason why that, because we're bringing in all these billions and billions of rows of data. You always have data corrections that come back in. So we've brought in 30 billion rows worth of data. We've ran our set of patterns and analysis against this. Cases have been open, alerts have been assigned, they've worked through a process, and then all of a sudden you get back from one of your source providers. By the way, the issue for the month of June and July, the buy-sell codes were flipped from B to S. So when you were buying, you're actually selling, and they were vice versa. So everything that you've done is bogus. It's all wrong, right? So how can I reprocess that? And unfortunately, and so we would try to optimize on solutions around that, around the ETL and trying to minimize the data correction issue. The problem of it is then the users suffered in their day-to-day job, which was painful for them. And the last thing I would advocate is that a big thing that we've been doing is really pushing Agile, in Scrum. So through this evolution of change, we've adopted our process and we're actually using like Scrum and having the users involved so that we can actually quickly pivot. And you can't know everything up front. So let's give them little bits and pieces, and then it'll end up changing what your solution is along the way. The IT profile, the one that was out there, that was actually, I kind of call it like our Post-it note moment. We were working on a completely different problem space and researching of like data mining, and one of the things that we were having problems with is pulling all this data. And so we built like just a little quick prototype, and one of our users saw it, because we were doing that internally within technology as part of a research, and they were like, that's what I want, right? And it was, it really happened out of happenstance that became, one of the products that we ended up bringing forward. So with that, I'll open it up to questions. And
please join me in thanking staff for an excellent presentation.
That's an excellent presentation. Thank you.
Thanks.
Looking at a real-world scenario, I've read that certain fund managers have admitted that in the past they can use as little as $5 million to suppress the price of a stock by killing momentum whenever a rally occurs. Is price action and momentum something that you capture in your data analytics and something that you analyze for? And what technology did you use to do that?
We do. So I will say we do we have some different techniques that we try to be able to do where we model it. I can't really get into specifics around this, but the net effect is that we look for changes in trends within the stock within the particular date. And we're looking for those sort of velocity, or like where the market makes these little ups and downs. Where the money making opportunities is when things move from an up to a down or vice versa. So it's in these pits and valleys. or like in an extended run. So we try to find areas of, so typically where you're finding areas of interest, we have a set of patterns that kind of focus on that. Other ones look at more aggregate of what are general movements within the data. But we do look for momentum swings within the data, and is there a way to be able to, is that incorrectly influencing the pricing on the stock?
Other questions?
Scott, does he deserve that was a good question.
Oh yes, I'm sorry.
Yes,
I got a couple of handout goodies here.
I thought they were all your business cards.
No, there's not that thick.
I have a quick question. So you guys are doing the trends and analysis on it. Do you incorporate any types of machine learnings into your processes?
Not really. So a big piece of what we do, it's really all historical analysis. So the typical techniques that we're doing are one, we'll do a lot of it is sequence and event matching within our anomaly detection. So you're looking for a series or a sequence of events. Once you've detected that, then you're also looking for a repeated pattern in practice. Like, is this person, one instance of that, trying to prove market manipulations, you got to prove intent. And just because like you saw one order jump ahead, that doesn't necessarily, it may look like an exception, but some of these ones you're looking for patterns in practice. But we typically are doing like sequence type, event matching in that area. We run various different regression techniques where we look to see deviations from the trend and out of the norm. Those are a couple of the most primary techniques that we're applying in the area.
Thanks for the great talk. I'm Sanjay with Ernst & Young. And what really appealed to me about your talk was this idea of building data structures for more sophisticated analyses. So I have done some work in network analysis, and a lot of the business challenges you mentioned cited
very much the same. It's
invoked in me.
It's the same problem when you're looking at like call detail or network switch information. I mean, it's like just vast amounts of information there.
Yeah. So I was wondering if you could talk a little bit about the data structures involved with providing the analysts with the fundamentals in order to derive the insights. So have you guys thought of networks? I think you did in one of your slides. And how does that relate back to identifying certain culprits, whether they're institutions or people? So like what's the unit of analysis or unit of observation that you're looking at?
So let me start kind of like backwards there. So the unit of observation, or we bring in, so there are three primary event types that we bring in. One is all the order information. We bring in so from the exchanges that we regulate, so the NASDAQ, the NYSE, BATS, Direct Edge, CBOE, the Amex, we bring in all of the event information. So as an order gets put onto an exchange, and then all of the various different hops that particular exchange occurs inside of that, we get all those different items that happen on the exchange, either until it gets either executed, canceled, or routed out. We also bring in, we have a system called OAT, so we get all the firm level information. So from this is Bank of America, Fidelity, E-Trade, et cetera. They have an obligation to send us all of the equity order information. So from the origination, we actually can see where, and they have to say, where did they route it? Did they internalize that trade? And it was executed and then reported through what we call a trade reporting facility. Was it routed out to a dark pool, and was it executed over there, which then ends up being reported into a reporting facility, or did it get routed to an exchange? So what we end up doing is really building that graph. We get the firm level information and all the exchange level information, and then we have to piece all of that together. The difficult items there is that each of these exchanges, almost all of their every exchange, they're proprietary, right? So they have their own pricing and ordering, and they have their own order execution systems. So a big piece of what we have to do is normalize, and really what we create is what we call a cross-market model that allows us to actually look at all the data across the exchanges, so that then we can see activity that might be getting sharded across. Is a big thing that we do there. But yeah, the unit of granularity are like all these order, quote, and trade events, typically, as well as other system events, right? If they do a halt, a suspend, that type of thing.